Wherever the need arises, the thunderous pulse of a helicopter will fill the skies of the next century. Yet the helicopters of tomorrow will not only look different, they will behave differently. There will be gunships built to destroy tanks and armored vehicles. Others will be reconnaissance scouts, scanning for threats beyond the horizon. Future helicopters will take off, straight up, fly like an airplane, and deliver troops into a war zone. Others will revolutionize how police fight crime and save lives. Standing in the dawn of a new millennium, the coming of age of stealth technology, combined with a revolution in digital video simulation, promises to open a new chapter in the history of the whirlybird. The AH-64D Longbow Apache is as mean as it looks. Prowling the skies day or night, rain or shine, the Longbow gives its crew an edge never seen before in helicopter warfare. Armed with the world's most sophisticated and lethal gunship, Apache pilots are brimming with confidence.
Flying the Apache, specifically the Longbow Apache, is a tremendous thrill. It's a great responsibility. It's very, very challenging, but it's also extremely rewarding, and I can't think of anything else that I'd want to do.
I think most threat tankers or any sort of armor guys realize, even from Desert Storm, that when the Apache rolls on the battlefield, it's time for them to stop and get out and start walking home.
The predecessors of the Longbow were developed to respond to the U.S. military's needs in Vietnam. The Hueys that arrived for service in 1962 performed admirably. Yet crew members were forced to use manned machine gun fire for cover as pilots swept earthwards to pick up and unload passengers. The problems stemming from the Hueys' lack of armament led to the introduction of the Cobra as the air war in Vietnam escalated to new heights. The Cobra was the first true attack helicopter to take to the skies. Pilots were in awe of the Cobra's speed and agility. But what really impressed them was its knockout punch. Armed with turret machine guns, grenade launchers, and 19 rockets on each stud wing, the Cobra was one of the great tactical successes of the war. The U.S. military continued to modify and improve the Cobra after its service in Vietnam. New generations of the aircraft proved worthy successors of the family name. The Cobra maintained its prestige as the most feared bird of its kind. Then a revolution in attack helicopters produced one of the most frightening machines of all time, the Apache. This Apache is the ultimate in modern gunships, an easy-to-handle helicopter that was also a true weapon of war. Its performance during the Persian Gulf War left military personnel awestruck. Yet the U.S. continued to improve its Apache.
This is the Army's newest attack helicopter, the AH-64D Longbow Apache. Its primary mission is the destruction of enemy armor. The primary weapon system on the aircraft is the Longbow Hellfire missile and the semi-active laser-seeking missile.
Screaming straight and level at 140 knots, the Longbow closes on its target. On board is a deadly combination of rockets and Hellfire missiles.
Longbow Apache is designed to fly and fight primarily at night. To facilitate this, the crew uses two forward-looking infrared sensors. The pilot night vision sensor up on the top here is primarily used by the pilot who occupies the aft crew station, and the target acquisition designation site has two function purposes. It can be used for targeting. It has a direct view optical telescope. It also has daylight television and also a FLIR. The FLIR is a dual purpose for targeting and also for pilotage for the co-pilot gunner who sits in the front seat.
In the world of helicopters, safe and accurate navigation fades with the setting sun. But the Apache's sophisticated radar and night sensors lift the cloak of darkness, giving pilots digital images of the terrain ahead. The information is viewed in the crew's helmet display system.
The FLIR image that is projected by the FLIR sensor, either the pilot night vision sensor or the target acquisition designation site in the nose of the aircraft, video image is displayed to both crew members over the helmet display unit, and allows them to keep the aircraft clear of terrain, to navigate the aircraft at night, and also to locate enemy targets and to engage those enemy targets while engaging at night.
With the night vision system, Apache crews fly just as easily at night as they do during the day.
This is the heart of the Longbow Apache's fire control system, the fire control radar. It's used to locate, detect, classify enemy targets. It also allows us to feed information as target location, speed, direction of movement to the Longbow Hellfire missile. We can also send that information to other Longbow Apaches for target information.
Locating and identifying the enemy is the first order of battle. Closing on the target, the Apache's fire control radar sweeps the entire area, pinpointing all ground and air forces. The radar's vast coverage allows the pilot to locate and engage hostile forces from an arm's length. In seconds, the information is processed, analyzed, and displayed in the Apache's crew station. The next order of business is subdividing and prioritizing sections of the battlefield. By determining which areas are high threat and which areas are no-fire zones, the Apache crew isolates friend from foe. The information is relayed to ground commanders and uplinked to satellites in next to real time. Once the commander has access to the data, he selects the target and establishes a plan of attack. Orders are transmitted digitally and displayed in the Apache crew station. Arriving at the target zone, the Apache radar is unmasked, detecting and isolating up to 256 separate targets. After honing in on his primary target, the Apache crew chief transmits what he sees to members of the Apache team. Each pilot now has his own designated fire zone, minimizing the chance of overlapping kills. The fight plan determined, the Apache engages the enemy and launches its missiles. Each gunship assesses the attack and passes the data to the Apache team leader. The team leader gathers the battle damage reports and transmits them back to ground commanders, who analyze and conduct a post-mortem.
By taking this information and leveraging it throughout the battlefield, we can significantly increase our capabilities as a team to affect a specific enemy or threat.
Armed with digital data link technology, Apache forces coordinate attacks, changing the battle scene instantaneously.
The H-64D Longbow Apache is the most capable and most lethal attack helicopter that is out there anywhere in the world.
All the missions that you can imagine when we have rapid target acquisition or specific optics, the Apache or the Longbow Apache can execute that mission.
Experts often refer to the next war as the information war. The force that can put information into the hands of its commanders first will have the edge. In these high-tech battles, the Longbow Apache will be an invaluable weapon. The menacing attack helicopter is already developing quite a reputation. Though the details are classified, recent competitions indicate that the Longbow's ability to engage and destroy targets is unparalleled in the world of gunships. The Longbow can hit moving targets from over 5 miles, a distance the U.S. Army hopes is sufficient to prevent future enemies from ever knowing what hit them. Looking down at the blue waters off the coast of Oregon, there appears little reason for concern. A merchant ship is cruising quietly as it awaits the arrival of a harbor bar pilot, who will board the ship and guide it safely to port. Yet the waters here at the mouth of the Columbia River have earned the right to be called the graveyard of the Pacific. For 150 years, pilots have made the treacherous ride, approaching the ship in a small boat and climbing aboard with the help of only a rope ladder. Today, the arrival of the pilot will be not by sea, but from the air. The air-to-ship transfers protects pilots from the hazards encountered when boarding a ship from rough seas. It is the revolutionary NOTAR system that allows the explorer to change the process of the pilot-to-ship transfer. Helicopters equipped with NOTAR are distinctive because they have no tail rotor. Traditionally, tail rotors have provided thrust and directional control for the aircraft. Yet they also produce excessive noise, and if damaged, can leave the pilot helpless. The NOTAR system eliminates the need for a tail rotor, making today's choppers safer, quieter, and easier to handle. The technology that makes NOTAR possible consists of an enclosed fan, a circulation-controlled tail boom, direct jet thruster, and vertical stabilizers. Low-pressure air forced through 2 tail boom slots makes the main rotor downwash hug the boom's contour, creating a lateral lift that counteracts most of the main rotor's torque. The thruster, in turn, provides directional control. What's more, potential loss of tail rotor effectiveness is greatly reduced because the fan is located inside the tail boom, where it is safe from trees and power lines. The advanced technology of the NOTAR system makes for unparalleled performance. Pilot Channing Morse works at Boeing's facility in Mesa, Arizona. A typical day at the office for Channing consists of testing the handling qualities of NOTAR-equipped aircraft.
Well, it certainly surprised me when I started flying NOTARs to find out that I could do a lot of things in them I couldn't do with a tail rotor. When you get a helicopter with a tail rotor in a crosswind, particularly a crosswind from the left or the tail, they vibrate a lot and they're very difficult to control. And that pointed out to us maybe we had a good idea. We'll start out with right side of our flight, and we're going about 25 knots or so here now, which is a pretty extreme wind for most helicopters. particularly this size. And then I'll turn the tail into that 25 or 30 knot wind now. And you can see it's just as smooth as it was in forward flight, which is pretty unusual as far as helicopters with a tail rotor go.
With the NOTAR system, Channing is able to keep complete control of the helicopter, even while performing the most difficult maneuvers under difficult circumstances.
And what I'm going to do here is a 360-degree turn. We'll wind up in rear flight again. A very, very difficult maneuver, if not impossible, and most helicopters can't do it anywhere near this fast. And you can see that's a very quick 360-degree turn for any helicopter in any wind. When you add to the fact that I did it in about a 50-knot tailwind, it's particularly impressive. One of the big advantages of the helicopter is you can do this kind of thing and still fly. It's hard to imagine that Cessna over there flying backwards.
But NOTAR helicopters are capable of more than aerial trickery. Imagine yourself stranded in the cold, unable to move on a snowy mountainside. A NOTAR helicopter could be your only chance for help. With extreme landing capabilities, even on 20% grades, NOTAR helicopters can put rescue crews in touch with patients, even in the harshest climates. Whether they're used by emergency response teams, the military, law enforcement, or search and rescue crews, the advantages of the NOTAR can often mean the difference between life and death. With their lack of tail rotors, NOTAR helicopters not only save lives, they keep their passengers out of harm's way. Studies show that tail rotors are to blame for 20% of all helicopter accidents. NOTAR helicopters are not only the safest in the world, they are also the quietest. So quiet, in fact, that they're the only helicopters allowed to fly over the Grand Canyon and other breathtaking national parks in the United States. The low noise output of the NOTAR system is a source of considerable pride for the manufacturer. NOTAR-equipped helicopters are already making their impact felt on modern life. Quiet and safe, with handling capabilities that once seemed light years away, the future of the commercial helicopter is arriving. Look for the NOTAR system to set the standard for helicopters in the 21st century. This morning, motorists crossing a bridge outside of Moscow are greeted by pilot Alexander Velovich and his Ka-50 Black Shark helicopter. Most of the commuters probably have no idea they are looking at a state-of-the-art gunship that is Russia's answer to the Longbow Apache. The Ka-50 Black Shark was conceived in the twilight of the Cold War. Soviet leaders were relying on their well-developed military establishment to protect and expand their political control. The first priority of the Soviet Defense Ministry was to develop a heavily armed combat helicopter. Their efforts produced the fearsome Mil-24 Hind. With its small, stubby wings, allowing high-speed liftoff, even while carrying weapons, the Hind's status as a combat helicopter was confirmed with its devastating performance during the Soviets' war against Afghanistan. Following the success of the Hind, the Soviets debuted the prototype of their Havoc helicopter in 1982. Early testing showed off its powerful arsenal. The Havoc borrowed from the design of the Mil-24 Hind, featuring the same rotor and engine. While smaller than its predecessor, the Havoc was still a large target. It weighed 11 tons, or 20% more than the American-built Apache. The Soviets continued to search for the combat helicopter to face down NATO's ever-improving tanks and armored vehicles. The Soviets were looking for a 21st century attack helicopter. The search came to an end with the Ka-50. The product of 2 decades of research, today's Black Shark is one of the world's most sophisticated and versatile helicopters.
Our helicopter has multiple uses. It can perform many functions. First, like all helicopters, it can perform a planned flight, according to the route with some fighter task, acquiring a target, locking it up, and eliminating it. It also can perform intelligence gathering. For this, it can work in an operative mode. It can perform combat patrol, receiving and transmitting information, and commands concerning targets.
The most striking distinction between the Black Shark and its Western counterparts is its coaxial rotor layout. 2 rotors provide optimum engine thrust, allowing it to reach higher altitudes. The system provides greater acceleration and top speeds. But what really impresses test pilot Alexander Velovich is the Black Shark's agility.
Compare, for instance, a speed skater running a race. When he is moving in a straight line, he can keep a straight movement. But when he makes a turn, he tilts his body. The same happens during the flight. If we were flying straight, it is one thing. But when a helicopter moves laterally, the pilot feels a completely different sensation. It is much more comfortable.
As Cold War suspicions continue to wane, more about the Black Shark's radar and weapon systems begins to trickle westward. Its lethal cargo includes up to 12 air-to-air missiles and as many as 20 122-millimeter rockets. For threats that are too close, there is always a .30 caliber machine gun. Aside from what is discerned from this rare footage, little is known about the Black Shark's radar and electronic gathering systems. The Russians are keeping this a closely guarded secret.
Generally speaking, this machine is a modern one. I could say it is the forerunner of the Russian and foreign helicopter industry by 10 to 15 years. The technologies that are used here, well, one should not discuss.
What does beg discussion is how the Ka-50 stacks up against its Western counterparts. At least on the surface, the Black Shark's speed, maneuverability, and firepower rival the Longbow Apaches.
Well, all around the world they compare Ka-50 to Apache. I, for one, would not compare Ka-50 to Apache. First, the Apache is lighter than our machine. Also, it does not have the same armor. It is not as heavily armored. It has fewer weapons than the Ka-50 does. All this means that our helicopter, as I said, is a different machine. That is why you can compare the 2 machines only in the air when you meet an Apache pilot face to face.
Like its competitor, the Black Shark can go to battle day or night. Its ability to endure punishment from high-caliber ground fire gives the pilot the confidence he needs to fly into hostile fire. The Black Shark is capable of launching high-precision SI armor missiles from ranges as far as 6 kilometers. Since the late 1980s, the Russian armed forces have experienced drastic reductions in military supplies and equipment. This trend is expected to continue. In particular, the number of combat helicopters will be reduced by 45% by the year 2000. The downsizing means that the newly emerging Black Shark will carry the burden of Russia's proud helicopter force well into the next century. At the United States Naval Base on the Patuxent River in southern Maryland, this V-22 Osprey sits poised to fly. The Osprey behaves like no other bird in naval aviation. Part helicopter and part airplane, it takes off straight up, and with the simple flick of a switch, helicopter becomes airplane in just 24 seconds. This morning, the Osprey project team is relieved to see blue skies. It's been raining for over a week. This is their first chance to fly.
Well, we're test pilots. Our job is to make sure the airplane can do the envelope that the contractor promised before we hand it over to the Marines.
HAX, as the base is known to locals and Navy folks alike, is the first stop for any Osprey coming off the assembly line. Here, the aircraft are put through evaluation before final production designs are completed.
Well, we've got 3 aircraft out right now. The 2 just launched and ours is going to follow. The first 2 that went out are doing high angle of attack and high gross weight work, and then Bill and I are doing some avionics work. We're going to be doing some pull-ups and pushovers and some flat turns. Well, I look forward to coming to work every day. It's we get a new process that we're working through every day. We got a lot of technology that's developing here, so we stumble across new little glitches and we get to work on them, work through them, and it's exciting. It's challenging.
The Osprey is a joint effort of Bell Helicopter and Boeing. Boeing builds the fuselage, avionics, and the fly-by-wire control systems. Bell puts together the wing transmissions, rotors, and engines. The heart of the Osprey is the revolutionary tilt rotor design, which allows it to take off vertically like a helicopter, then fly with the speed and range of a turboprop airplane. Yet tilt rotor technology was not an overnight discovery. Its roots lie with the XV-15, developed by Bell Helicopter and first flown back in 1977. Now these test flights at PAX are perfecting the tilt rotor and ushering in a new wave of helicopter technology.
But we've always known that there have been limitations to helicopters. Those limitations are speed. About 150 knots is about all a helicopter will do. So to go faster, we looked at many different types of machines. And the tilt rotors seemed to be an approach that we kept coming back to.
The V-22 has its engines on its wing tips. Hydraulic motors are used to tilt the big engine nacelles down, so that the airplane will fly straight and level.
Its purpose is to take the capabilities of a helicopter and an airplane and combine them into one platform. Specifically, utility to where you can carry troops. And we're able to hover like a helicopter for pickup and landings, but then we're able to go 500 nautical mile radius and carry those troops twice the distance and twice the speed of a helicopter.
We combine both the best of a helicopter and its vertical takeoff and landing ability and the abilities of an airplane to fly very efficiently. So anytime we will have to take off vertically and go some distance, anything over, say, 50 to 100 miles, the tilt rotor is going to become the efficient tool in the future.
The Osprey will be a welcome sight for the U.S. Marines, who like an aircraft that can pick them up and put them down in tight spots. A typical Marine mission for the V-22 will involve taking off from an amphibious ship 50 miles offshore, flying 24 combat Marines into the battle zone. The Osprey will have the range to evade hostile threats. go back to the ship, pick up another load of Marines, and take them to the drop zone, all at twice the speed of any helicopter today.
The biggest advantage we think that the V-22 offers to the Marine Corps is it helps them do what they call their maneuver doctrine. It allows them to outmaneuver an enemy. They can move their troops and their equipment around the battlefield more rapidly than the enemy can react. And that allows a smaller, lighter force to defeat a larger, slower force. And that's what the Marine Corps is all about.
The United States Marine Corps isn't the only branch of the service eagerly awaiting the arrival of the Osprey. The U.S. Air Force has ordered it for use in tactical missions carried out by special forces.
The second mission for this aircraft will be the CV-22 and Special Operations Forces that the Air Force is going to put in use to support a SOCOM. In that mission, they're taking a smaller load, but they're taking it a very long distance. And our requirement there is to be able to go on the order of 500 miles radius, drop them off in a small zone vertically, and then come back 500 miles. So in that case, it's a little different mission. But again, because of its unique capabilities in the airplane mode of going long distances, it can do that mission as well.
Pilots who step into the Osprey know they must rethink the way they fly. Sometimes they assume the mindset of a helicopter pilot, taking off vertically, flying at low altitude, hugging the terrain. Sometimes they're airplane pilots, streaking across the sky at 400 knots. The combination of tasks makes for a kind of split personality.
The primary mode of flight is going to be airplane mode, where the nacelles are down at the horizontal. That gives you the best speed, the best range, the most efficiency. And then when you get ready for the landing, you're going to reconvert to the helicopter mode.
This airplane, when you take off, is going to be feeling like a helicopter. In the helicopter mode, it feels like a helicopter. It's got a little bit of vibration like a helicopter does. Once we take off and get into the airplane mode, it takes a few seconds, probably 30 seconds to get in the airplane mode, and we're up above 130, 150 knots. At that point, it's flying smooth as silk. It's like an airplane. It's like a turboprop, the same kind of commuter airplane we would be flying with out of a normal airport today here in the commercial world.
When you first do that first conversion down to airplane mode, and you see those big prop rotors go right by the windscreen, that's when you realize this is a different aircraft.
The V-22 Osprey team has indeed created a new kind of flying machine. The Osprey's capabilities continue to fascinate the aviation world. The manufacturers have already developed civilian applications as a possible solution to the increasing level of airport congestion. The military, the Osprey will replace the Navy's aging Chinook fleet. As it takes off vertically and flies at high speeds, the V-22 will be the new transport for tomorrow's soldiers. When war came to the Persian Gulf, the call went out for the Apache. The attack helicopter was loaded into massive C-130s and C-5s for transport to the Gulf. In the early morning of January 17, 1991, 8 Apaches crossed without lights into Iraqi territory and bore down on their targets, 2 enemy radar stations. The choppers then let loose a hail of laser-guided Hellfire missiles, hydro rockets, and cannon fire. In seconds, a radar-free corridor had been established. U.S. aircraft could now enter the war zone undetected. The Apache had struck the first blow of the war. Yet there was one drawback to the Apache's performance. Its large load of heat-producing weaponry made it easy to detect on radar. This confirmed what U.S. engineers had been thinking, that new generations of helicopters had to be stealth. 5 years after the Apache's domination in the Gulf War, the Americans were ready to debut their latest chopper. In January of 1996, test pilots Russ Stiles and Bob Gradle climbed aboard the RAH-66 Comanche helicopter and prepared for the aircraft's first flight. The defining moment had arrived for an ambitious project that dated over 10 years to when the United States took its first steps toward replacing its aging fleet of scout and attack helicopters. For pilots Stiles and Gradle, the test flight of this highly anticipated helicopter represented the most significant challenge of their careers. The designers of the Comanche had a clear goal: build a helicopter capable of dominating the battlefield by penetrating undetected deep into enemy territory. Engineers, designers, military personnel, and others who had helped bring the Comanche to life gathered quietly to await the first takeoff. As the stealthy chopper rose into the air, relief was seen on the faces of those who had worked on the Comanche. The door was opened for the helicopters of tomorrow. The Comanche showcases new technologies of the helicopter industry. It can fly undetected over enemy soil, a critical task in modern warfare. The Comanche operates 24 hours a day in any kind of weather. It is the first system that can detect and report biological and chemical contaminants. The Comanche is a joint effort of Boeing and the veteran helicopter builder Sikorsky. From the project's inception, industry experts worked with scientists from NASA and other research entities to explore rotor and blade configurations and composites. To retain the cloak of stealth, a radar-absorbent graphite epoxy was chosen. The Comanche features an internal compartment for weapon storage, retractable landing gear, and an engine exhaust suppressor, all of which maximize the aircraft's ability to patrol the skies undetected. An infrared piloting sensor on the Comanche's nose is up to 6 times more effective in finding targets than those of current helicopters. Targets even in low visibility. The Comanche is powered by twin 1,400 horsepower engines, which allows pilots to climb vertically at 1,500 feet per minute and cruise at 165 knots. In its armed recon mode, the Comanche features a turreted 20mm Gatling gun, which fires up to 25 rounds per second. Weapon bays open to fire missiles in just 3 seconds.
Going into a cloud. I'll wait till we get to some sun. Beautiful. Yeah. Real fine.
The story of the Comanche's development is also one of the advances in simulation technology. Inside a simulator, a pilot encounters virtual scenarios that mirror those of the actual mission. From the experience gained on simulated flights, pilots can provide information on the performance of the plane to the manufacturer and the design team. In developing the Comanche, pilots tested the handling of the helicopter on simulation programs that posed a variety of environmental conditions. The computer-driven battle management system and helmet-mounted displays that allows for head-up flying are just two more features that endear the Comanche to its pilots. Once testing was complete, actual construction of the first prototype began. The ability to thoroughly test the Comanche's performance before its actual production led to a significant reduction in the cost of the helicopter. As a reconnaissance helicopter, the Comanche can sneak undetected into enemy territory, identify location and weaponry, and transmit it back to ground commanders. If the Comanche is engaged in battle, it brings its choice of up to 14 Hellfire or Stinger air-to-air missiles to the fight. When the action gets close, the Comanche can also unveil machine guns, which hide out in undetectable bays. Loaded with the latest weaponry and high-tech engineering, the futuristic Comanche stands ready for battle. With its hopes for the development of the Comanche now realized, the U.S. Army knows it will enter the next century with the most sophisticated armed reconnaissance helicopter in the world. Imagine you are a helicopter pilot, flying a mission over the hostile North Atlantic. Rough waters and high winds are making your life difficult. As you go about your work above the icy waters below, you have forgotten that you are flying this mission not from the cockpit of a state-of-the-art helicopter, but from the comfort of your office, which in this case is a flight simulator. With the merger of video technology, information compression, and advances in the digital domain, new technology is closing the rift between reality and simulation. Virtual flight will be a critical part of the training of helicopter pilots during the next century. As image-generating technology continues to be perfected, more applications will be discovered. Flight simulators offer the chance to gain experience with an aircraft without ever leaving the ground. The ultimate goal is for pilots to train on flight simulators and transfer all of their learning experiences from the digital realm to the actual plane. Virtual training not only helps the pilot, it also helps the bottom line. It is much less expensive to operate a simulator than to fly an actual chopper. Flight hours are reduced, fuel is saved, and no one's life is put in danger. This simulator was built for the Royal Air Force to help train their Sea King pilots. Rescue pilots who fly the Sea King enter the simulator and find the artificial crew station is almost identical to the real thing. This simulated ocean was developed using a basic wave equation which applies wave size, frequency, motion, and direction. The instructor has total control in creating various training environments, ranging from calm, smooth oceans to a violent tempest. These are the environments a pilot encounters during air-sea rescue missions. Wakes and rotor wash are included to give more realism to the pilot's experience. Creating virtual worlds where pilots can test their mettle against the worst flight conditions has an enormous impact on the world of aviation. Because helicopter pilots spend so much time careening at low levels, everything about the ground needs to be as realistic as possible. The goal is to create the many potential hazards and obstacles that would confront a helicopter pilot during a real flight. Simulator programs are developed for a variety of users, depending on the kinds of conditions they're likely to encounter.
What you're seeing here, this is what we call a free flight database, which means that when the database is developed, it's developed within a certain geographic area, and within that area the pilot can fly anywhere.
Digital maps for the chosen topography are loaded into the database. This information is read into tool sets, then animated into 3D images. Textured maps consisting of trees, fields, and obstacles are then constructed to fit the specific terrain.
What you're seeing here is a desert scene from Southern California. This is one of the most complex models that we've built in terms of just the general size of the area of the terrain, and also the number of models that you're seeing within the scene. If you notice all the moving models, all the tanks in the display, this particular image generator can handle up to 1,000 models moving simultaneously. The tanks themselves have 3 degrees of freedom, which means that the tank body can move, and the turret and the gun can move independently of one another.
Greater reliance on simulators than actual flight doesn't go over well with some military leaders. Yet in the fiscal austerity of a post-Cold War age, most have been quick to concede that simulators are rapidly becoming the instructors of the future. As the technology continues to become more realistic, those who fly in simulators can be assured they will be prepared to meet the challenges that will face them in real life. Advanced technology is rapidly moving tomorrow's choppers from design screens to cloud-streaked skies. Improvements in radar, tilt rotors, stealth technology, and flight simulation has revolutionized the world of the whirlybird. By the turn of the 21st century, an awesome new array of reconnaissance, attack, and rescue helicopters are poised to leap skyward.